Hello everyone, this is Mrs. Ortiz and we are covering for Algebra 2 section 4.4 part 2. So we're going to factor quadratics when a is not equal to 1 in this video. So to get this video started, I'm actually going to do 3 examples that are not on your notes. So you might want to find a space because it's really going to help us set up understanding for 24 through 32 when we come back and do those in a few minutes. So in order to factor these with the area model, you're going to do the highlighted ones, 24, 28, 31, 32, and I'm going to do the rest, okay? So when we do set these up, in order to be able to set up the area model, we have to set up the diamond first, okay? So remember, our goal is going to be to set up the area model so that we can factor. But in order to factor, we need to have 4 terms, and we only have 1, 2, 3. So to get 4 terms, we're going to use the diamond, okay? So just like in the first unit, the first part of this section. And up here, we've got A times C, and down here, we've got B. So we need to identify A, B, and C. So A is equal to 2, B is equal to 11, and C is equal to 5. And A times C is 2 times 5, which is 10, and B is equal to 11. And then remember, for these 2 numbers, we're looking for 2 numbers that multiply to 10 and add up to 11. So the factors of 10 are 2 and 5, or 10 and 1. And 10 times 1 is equal to 10, and 10 plus 1 is equal to 11. Okay, so what the diamond has done is it has given us these 2 numbers, okay? And what we're going to do is we're going to take our 3-term trinomial, 2x squared plus 11x plus 5, and we're going to split this middle term in order to make it a 4-term trinomial. Okay, so we just bring down our first term. It stays the same, 2x squared. And then our 11x, we use the diamond to split that into 10x and 1x. And 1x can just be written as x. And then our last term, our c, stays the same as well. That's a 5. So now we can fill our area model with 4 terms. Okay, so in our first box, 2x squared, followed by 10x, followed by x plus 5, okay? And then you're just going to use the GCF in the rows and the columns to go ahead and factor this. So if we look at this column right here, 2x squared and x, the GCF here is x, okay? And then if we go for this spot right here, we know that x times what is 2x squared? That's 2x, so 2x times x is 2x squared. And then if we fill this spot in, 2x times what is equal to 10x? That would be 5. And then if we go down here, we know that x times what is x? Well, that would be 1. And then let's check this cell. Is 1 times 5 equal to 5? It is. Okay, so that's it. We have factored. So this is x plus 5 times 2x plus 1. And we're just going to write that as a factored binomial. So 2x plus 1 times x plus 5. And again, remember, the order that you put those 2 binomials in does not matter. Okay, so that's it. So the process is, let's kind of summarize the process here for a second. You're going to, I'm just going to write in this space. You're going to, step 1 is to use the diamond and AC method. So that's what A times C is. It's called the AC method in the diamond. Okay. So use the diamond and AC method. So you're just going to complete the diamond. Write the trinomial. So that's 3 terms as 4 terms. and then you're going to fill out the area model box. And find the factors. Okay, so that's the process that we're going through. Okay, so from here on out, I'm just going to be doing a lot of examples, and so you can just follow along for as many as you want. My hope is that you're kind of working with me, or maybe even a little bit ahead of me, and then checking your work as we go. Okay, so here we go. Number 26, 7x squared plus x plus 8. So our first step is to set up our diamond. And up here we're going to do a times c, and down here we're going to put in b. So a is equal to 7, b is equal to 1, c is equal to 8, and 7 times 8 is 56, and b is equal to 1. So now we are looking for two numbers that multiply to 56 and add up to 1. Okay, so two numbers that multiply to 56 and add up to 1. So our factors of 56, we've got 1 and 56, 2 and 28. Let's see here. 4 and 14, right? And then 5, 6, and then we've got 7 and 8, and I think that's it. But we're looking for them to add, this is going to be positive, 56, and this is going to be positive. So we know that both numbers need to be positive, and we are looking for any of these pairs to add up to 1, and they're never going to. So that means this cannot be factored, and when it can't be factored, what you're going to do is you're going to write the word prime. So that is, it cannot be factored any more than what it is already written as. All right, and in this case, it can't be factored at all. All right, so we didn't make it very far in that one, but let's take a look at number 27. So we're going to start with the diamond, sorry. And up here, we're going to do a times c, and down here, we're going to do b. So a is equal to 5, b is equal to 18, and c is equal to 9. 5 times 9 is 45, and b is equal to 18. So we're looking for two numbers that multiply to 45 and add up to 18. So we've got 1 and 45, we have, let's see here, 5 and 9, we've got 3 and 15, and 5 and 9. And I think that's it. So we're looking for these two that, the pair that add up to 18, so that would be 3 and 15. And since both of these are positive, our numbers out here are going to be positive. Hopefully you're getting comfortable with filling in the diamond by now. And then we're going to use these two numbers to turn our 3-term polynomial into a 4-term polynomial. So the one that gets split is the middle, b. That becomes 3x and 15x. And then we just bring down a and c. So 5x squared plus 3x plus 15 plus 9. And then we're going to use those 4 terms to put them in our box. So we got 5x squared plus 3x plus 15x and 9. And we're going to look for GCFs in order to be able to factor. So let's look at 5x squared and 3x. So we're looking for the term in that row. The GCF of those is x. Okay, if we look at this column right here, we're looking for this spot, the GCF of 5x squared and 15x is 5x, and we can check, is 5x times x equal to 5x squared, and it is. And then we're going to look for here, we've got x times what is 3x, well that would be 3. Okay, and then if we're trying to fill this spot, we've got, well we can do this 15x, right? So 5x times what is equal to 15x, and that would be 3. And 3 times 3 is equal to 9, so that box fills in. Okay? And then that's it. You have your factors. 5x plus 3 times x plus 3. And so we're just going to rewrite them right over here. Okay. So continuing with examples. Let's see here. We should circle that so we can indicate it to be our answer. And we're going to go over here to number 29. All right, so number 29, and something that I have not mentioned in this whole video is every time you look at one of these, the very first thing you really should do is look for a GCF, okay? So if we look at our three terms, we've got 45x squared minus 30x plus 5. All of these have a greatest common factor of 5. So we can factor out of 5, and we're going to be left with 9x squared minus 6x plus 1. And now when we go to factor, we're just factoring this trinomial, and we'll just bring this 5 down with us for each part of the problem. Okay, so in order to factor 9x squared minus 6x plus 1, we're going to set up the diamond. 9 times 1 is 9, and negative 6 is b. We are looking for two numbers that multiply to a positive 9 but add to a negative 6. In order for those to be positive, a positive product and a negative sum, they both need to be negative. So negative 3 times negative 3 is a positive 9, and negative 3 plus negative 3 is a negative 6. So now that we have our two numbers from our diamond, we're going to split our b term to negative 3x and negative 3x, bring down c, and bring down a. Okay, and then we're going to go ahead and put this in the area model. So let's make our box. And our four terms are 9x squared minus 3x plus 1. Okay, so if we start with this column, we're looking for the GCF in this column between 9x squared and negative 3x. So we can take a 3x out of both of those. If we look for the GCF in this row between 9x squared and negative 3x again, we can do a 3x for a GCF again. Okay, and then for this row, right, we're going to do a GCF between negative 3x and 1. So that's going to be 1. Okay, except that we need it to be, let's check this box, because now we need to do we need to do 3x times something to get a negative 3x, and so we need this to be a negative 1. And then for this term right here, for this row, we've got, we know that this is going to be a negative 1, so negative 1 times what is a positive 1, and that's going to be a negative 1. And then just check everything, because the signs on that got a little bit funky. But, so check this cell, 3x times 3x is 9x squared, that's good. Check this cell, 3x times negative 1 is negative 3x, that's good. Check this cell, 3x times negative 1 is negative 3x, and negative 1 times negative 1 is a positive 1. All right, and then we have our factors. So we've got 3x minus 1 times 3x minus 1. Now, because this is the same factor 2 times, it's repeated, we can actually write this as 3x minus 1 quantity squared. And there's our final answer. Okay. Got one more to take a look at with you, and then you get to complete the rest. So 4x squared minus 1. This time we actually do not have a b term. So the first thing we need to do is take our 2 terms and change it into 3 terms. So we've got a and we've got c, but where are you, b? If it's not there, then we know, because b is the linear term, it should have an x on it. We know that we can do 0 times x, and that's going to be equivalent to that statement, okay? All right, so now that we have b, we're going to do A times C. 4 times -1 is -4. And put B, our 0, in the bottom of the diamond. And we're looking for two numbers that multiply to a -4. So now that we're multiplying for a negative, we need one positive and one negative, and add to 0. So 2 times -2 multiplies to -4 and adds to 0. All right, so we're going to split our 0x into 2x and -2x. Bring down our A and our C. 4x squared plus 2x minus 2x plus, minus 1. And then we're going to fill in our box. We've got 4x squared plus 2x minus 2x minus 1. And we're just going to look for GCF. So we'll start with this one. And that first row, we've got 4x squared and -2x. So a 2x comes out of both of those. Okay. And then 2x times, we can fill in this one, right? 2x times what is -2x? That's -1. And then we can do this spot right here. 2x times what is 4x squared? That's 2x. And then we've got this spot left. 2x times what is equal to 2x? And that's 1. Okay, so let's check everything. So 2x times 2x is 4x squared. This box checks. For this box, we've got 2x times 1, which is 2x. For this box, we've got 2x times -1, which is -2x. And for this box, we have 1 times -1, which is -1. All right, and then we have our factors. So we've got 2x plus 1 times 2x minus 1. Okay. And that's all. That is factoring when A is not equal to 1. So you've got a couple examples left there to do yourself. Have a great day. Bye. Okay. So here are the 3 questions. You might want to go ahead and pause and jot these down. And then I'm going to work through them here in just a second. So before we get into factoring when A is not equal to 1, we really need to make sure that we understand the area model that we've been using to multiply 2 binomials. Remember that a binomial is a 2-term polynomial. Okay, so x minus 7 is a binomial, and 4x plus 9 is a binomial. All right, and when we multiply them together, we can use the area model and set up a square and give each term in the binomial either a row or a column. So we'll start with x minus 7, put x in the first column and -7 in the second column. And then our second factor here, so factors are being multiplied, is 4x plus 9. So we're going to put 4x in the first row and 9 in the second row. And then we're going to multiply to find each cell, we're going to multiply the row by the column. So for this first cell, we're going to multiply 4x times x to get the product of that cell. So 4x times x is 4x squared. And then for this cell right here, we're going to do 4x times -7, which is -28x. For this cell, we're going to do 9 times x, which is 9x. And for this cell, we're going to do 9 times -7, which is -63. And then we're just going to write those out. So 4x squared minus 28x plus 9x minus 63. And we need to combine like terms to simplify. So -28x plus 9x is -19x. And then we just have our other 2 terms. Okay, so that's just a quick reminder of how we can use an area model to multiply 2 binomials together. Okay, so what we're going to do in number 2 is we're going to use the given area model to work backwards and write the product of the binomials. Another word for write the product of the binomials would be to factor. We are undistributing. Okay, factoring is doing the inverse of distribution. So we are going to undistribute this quadratic. In order to do this, what we're going to do is we're going to pick a row or column and look for the GCF in that row or column, okay? So it doesn't really matter where you start. If you start with the column with 3x squared and negative 2x, we are looking for the GCF between those two terms. So the GCF of 3x squared, oops, I don't want to write in highlighter. Okay, so the GCF of 3x squared and negative 2x is x. Okay, so the GCF here is x. And so what we're going to do is we're going to go up. We're looking up this column, and we know the GCF is x, so we're going to put it at the top of that column. Okay? If we were to do this row, if we're going to look for the GCF of the top row, we've got 3x squared and 21x. So if we're going to do the GCF of 3x squared and 21x, the GCF here is, well, we've got 3 goes into both 3 and 21, and we can take an x out of each one of these, so it's a 3x. So then we put a 3x here. And then we're going to check this box, right? Is 3x squared the product of 3x and x? And it is, okay? So then we're going to just it's kind of a puzzle that you're working backwards for. So then we want to know 3x times what is going to give us this 21x. Okay, so 3x times 7 is 21x, right? And then for this box, we want to know if it's negative 2x, what are we multiplying x by, this x up here? Okay, so x times what is negative 2x, and that's a negative 2. And then we're going to check this last spot. Is negative 2 times 7 equal to negative 14? And it is. Okay, so now that we have figured out what the dimensions of our box are, we can write this as a binomial. Okay, so we're just going to go backwards, and we're going to write this as x plus 7 as a binomial and 3x minus 2 as a binomial. So we've got 3x minus 2 times x plus 7, and it doesn't matter what order you write those in. So I just wrote it backwards than what I said it. Okay. So given a box, go ahead and factor to write it as the product of two binomials. All right, and number 3, it's the same idea except the box is not given. So it says factor the 4-term quadratic equation using the area model. So in number 3, we need to set up the box. All right, so we're going to zoom in here a little bit, and we'll go over so we can see the quadratic. Oh, I'm moving it, but that works. Okay. So we're going to create a box, and we've got this 4-term polynomial, and we're just going to put each term in a cell in the box. Okay, so we're going to start with 5x squared, and then we can put in negative 15x, followed by 4x, and then negative 12. Okay. And then we're going to do exactly what we did. So for each row and column, in like in number 2, so for each row and column, we are looking for a GCF. It doesn't really matter where you start. Okay, so if I look at 5x squared and negative 15x, the GCF for that row is 5x. I can take a 5 and an x out of both of those. We have 5x here, okay? And then if we know that this is 5x and we've got a 5x squared here, then we know that we need to multiply 5x by x to get 5x squared, okay? And then we can take this x and go work on this 4x. So x times what is 4x, and that's going to be 4 here. Okay. And then again, to get this spot, it doesn't really matter where you go. We can do 5x times what gives me negative 15x, and that is negative 3. So 5x times negative 3 is negative 15x. And then we're going to check this last cell. Is 4 times negative 3 negative 12, and it is. Okay. So once we have our area model worked out, we can write this as a binomial. So we've got x minus 3 as one binomial times 5x plus 4 as the other. Okay, and now we have factored a quadratic that has an a value that is not equal to 1. Okay, so that is all the setup information for using the area model. Let's go ahead and go back to those examples and see how we're going to go about doing that.